Okay, so here we have to sketch a polar equation where r is 2 times cosine of theta. It's very important for you to remember that cosine of theta is between the value of -1 and 1, which means radius, maximum of radius, max r, is going to be 2. So it'll decrease or hit the maximum of 2 depending on what the angle is. Also, let's recall what the cosine curve looks like. Right, it starts at 1, at pi over 2 it's 0, right? At pi it's going to be -1, and so on, right? So let's use that. Okay, we have to have a clear understanding of what cosine of theta looks like to be able to draw this efficiently. So when theta is 0, right, it's 1, so r is going to be 2. Okay, and at pi over 2 is 0, so it's actually going to be, when the rotation is all the way around, the length of the radius is 0. So it's 2, but gradually, right, because it's 1, and it's slowly shrinking, it's gradually going to, so as it rotates, it's not going to maintain this radius of 2. What it's going to do is it's going to get shorter and shorter and shorter until it hits 0. Okay, so it's going to look something like this. And then it's going to start growing again, right? So we're going to be multiplying 2 with these negative values, really small in the beginning, all the way up to -1, right? But it's a negative value, so the rate is going to be negative. So when we're rotating here, it's going to be negative. So it's going to come out on this side. So opposite quadrant of this second quadrant is the fourth quadrant. Right, it's going to do this, right? And when it hits 180, right, pi rotation, right, it's going to be -2 exactly. So it's going to be back here. So we're going to meet that dot, like that. In fact, it should look actually exactly the same as a top leap, top picture. I mean, my hand drawn it looks a little bit different, but it should be exactly a mirror image on the x-axis. Okay. And then when you go here, okay, we start at, so here we start at -1, we start here, okay. Okay, so this part right here represents this rotation, right? So we're still going to get a picture on this side, and we're going to start at -1, right? And then go back down to 0, right? So it's going to actually overlap this part here. Okay, so far what's happening is this, right? We drew this part. This is up to 90 pi over 2 rotation, and then like this until pi rotation, and then like this from pi to 3 pi over 2 rotation, and then here in the last quadrant, right, it's going to do the bottom part again. Okay, so for 2 pi rotation, from 0 to 2 pi, it just goes around the circle twice. Okay, so I'm sorry for my terrible hand drawing here, but this is actually an exact circle. Okay, note the smoothness of this curvature here, right? Following that, it's going to be exactly a circle, and we can actually prove that it's a circle by changing it to a Cartesian equation. Recall that from here, recall that r squared is equal to x squared plus y squared, and that x is equal to r cosine of theta, and the y is equal to r of sine of theta. Okay, so how do I get one of these expressions from here? Well, I have a cosine. It would be nice if I had an r. Okay, so what I'm going to do is multiply both sides by r, and I get r squared is equal to 2 r cosine of theta. So that can right there be changed to x, and this right here I can replace with an x squared plus y squared. Let's bring this over, and hopefully you can see that this is actually an equation of a circle. So if I just add 1 to both sides, like this, so I added these two ones, I get an x minus 1 squared plus y squared is equal to 1. This is a circle with center at 1, 0 right here, and radius of 1. So this confirms that this is a perfect circle with center located at 1 and 0 and radius of 1.